Hello, this is Hunter Gray going through this video demo. I'm going to start it by putting 8 into the ROM and then put 3 in. Make sure these are right. Write is at 0, read is at 1, accumulator's at 0. Click on the address. Let's see what happens when we change it from 1 to 2. Or 0 to 1, I guess. It'll change between ROM 0 and ROM 1. We want ROM 1, so we'll change it. We'll set the decoder to pick ROM 1. Flipped the AB switch to, I want it so it saves into the accumulator, or the register, the B register, and then set this on, run a clock pulse to save it in this register. Turn that off. Now we want 8. Let's change that. Let's go turn that. We want to make sure it's routed right to the immediate part, which it is. Now let's do subtraction, which I believe it is on. We need to enable the accumulator. Let's run a clock pulse. The answer is saved. Turn this off, and now I can run as many clock pulses as I want without any change to the accumulators or registers, particularly the store B and accumulator. Turn this on, giving an error because there's stuff. I need to turn read off. Now should say 5, which is 1 plus 4, 5. Now we want it to get written to RAM 6. So this is probably, let's get this value. RAM 6 selected. Now we want to set write on to write it in. Now we should clock to save this into RAM 6, and it is done. Is this machine digital or analog? It's digital because something can only be on or off or floating, but that just means it's unconnected and will give random results if you use it. You don't want that. It's digital because it's either 5 volts or negative 5 volts. A bit is one line in like a register or a data bus or anything. It could be just an on or off. Just one bit of information. Each of these registers have 4 bits. The registers, they save and hold the information. You can enable it and disable it and save it with a clock cycle. These registers, it's right here, 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 and here. And these are parallel in, parallel out, because all the data goes out in one clock cycle. You don't have to wait for it to piece every single bit out. It just comes out all at once on its own wire. But they're just clumped up in this demonstration so you don't have a bunch of wires running around. And that's it. Thank you for watching.